This is a lot of Rust code, and you probably think all this error handling is overkill for reading a simple config file in Rust. I do too. In fact, we can get rid of most of it. The reason this code is so verbose is that we need to handle different failure cases when loading a file. One is a potential I/O error when reading the file from disk. The other is a potential parse error when converting the content to the TOML format. And these are only two of the many errors we can get. But this isn't even the biggest issue. The biggest issue is that we need to define a single error type that encompasses all possible failure cases. In this case, the config error enum with different error types. And for something like loading a config file, this is overkill. Because as the function caller, I don't necessarily care what the exact error was. I just care that something went wrong. Instead, I like how simple this code is. I think we all agree this is much easier to read. In Rust, error handling can be quite annoying if you don't know which crates to use. And this is the beauty of the anyhow crate. It's one import, one return type, and we're able to get rid of more than half of the previous code. But there's another issue. Most Rust developers use anyhow because everyone else does, without really understanding why it's become the default choice for application-level error handling. So let's go over the 3 core features of the anyhow crate, so you know exactly when to use it and how to use it best. The first feature of anyhow is the custom result type, which helps us dramatically simplify error handling. So here's the load config function we saw in the beginning of the video. Instead of using the result type from the standard library, let's import the one from anyhow and use it instead. Notice that our custom error type is no longer needed. That's because the anyhow result type already comes with an error type built in, one that can represent any underlying error. So rather than defining our own config error enum, we only need to specify the success type, config. And just like that, more than half of our original code disappears. Feature number 2 of the anyhow crate are the context methods, which are a way to attach a note to an error. By default, the question mark at the end of lines 2 and 3 simply returns the error without additional information. So when reading the file fails, all you get is no such file or directory, instead of the exact path to the error case, or that you were even loading config. In a real production log, this is not helpful at all. The context methods fix that. The with context method lets you attach your own formatted message to an error. You hand it a closure, a little block of code that builds the message, and it only runs if something actually fails. So on the happy path, you don't pay any performance penalties by having the context attached. Alternatively, the plain context method takes a simple string when you do not need additional formatting of a string. With both the with context or the plain context method, your node gets wrapped around the original error. So the final error message provides a lot more information. You're not left guessing which file the failure happens in. And the third feature of the anyhow crate is the anyhow and bail macros, which are 2 quick ways to create and return one-off errors without having to define a custom error type. These macros become particularly useful when we have many error variants like these: a setting that is missing, a value out of range, or a reserved port error. Without anyhow, every one-off error means adding another variant to your custom error enum. That's a lot of manual code for simple one-off error messages. Fortunately, the anyhow macro can build an error straight from a piece of text. It takes the same fill-in-the-blank syntax as the very common printline macro in Rust. So dropping a value into the message is a single line without custom error types defined anywhere else. One caveat with the anyhow macro is that it only instantiates the error value. It doesn't return anything on its own. So if you want to exit the function with that error, you still have to return it or pair it with the question mark operator. On the other hand, the bail macro does both. It builds and returns the same error in a single step, which is why this line has no return or question mark operator. Both are already included for us within the bail macro. So when should you use the anyhow crate? Ask yourself one question. Is it enough for the function caller to know that the operation failed, but not exactly how? If the answer is yes, that's enough. Anyhow is a great fit. You get one error type, a readable chain of context, and no custom error enums to maintain. But if the answer is no, and the function caller needs to distinguish between different failure modes, you should consider using a different crate like this error instead. It lets you define typed error variants that callers can match on and handle differently. If you'd like a dedicated video about the thiserror crate, which is another super popular crate in Rust, let me know in the comments below. And if you're serious about learning Rust, check out our Rust Live Accelerator. It's our tailored mentorship program where we help developers go beyond YouTube videos, build production-grade Rust systems, and land their first Rust job. You can join the waitlist for our next cohort by heading over to letsgetrusty.com/join, or by clicking the link below. When you join the waitlist, we'll also send you our Rust developer roadmap as a small gift. So tap the link, join the waitlist, and I'll talk to you very soon.